Hello, everybody. Thank you for attending our webinar today. That's entitled A Window into Strategic Superiority. This is the next webinar offered up by Zygo Optics. My name is Joe Salemi. I'm the OEM Sales Manager for the Optical Components Group.
Hello, everyone. My name is Katie Zadrovich. I'm Zygo's Quotation Manager for ISR Windows and other custom optical flats.
So as government spending on defense ISR capabilities increase, we want our customers to understand the potential risks early on in the design phase so we as a group can avoid critical pitfalls later. So that being said, we're going to jump into our webinar. Thank you all for joining. I'm going to turn off my camera and we'll get started. All right, so as Katie mentioned, she is our Custom Optics Quotation Manager. Here is our contact information. If you would please submit your questions via the Questions tab in the Go to Webinar toolbar. We'll try and get to all your questions at the end of the webinar. If we run out of time and we can't get to every question, Katie and I will contact you with the answers after the webinar, and we'll also provide our contact information. So many people think of Zygo as an instrument company, but we actually began as an optics manufacturer in the early 70s. And at the time, we weren't thrilled with the available metrology that was commercially available. So Zygo then created the very first commercial interferometer. And since then, we've been making the world's best optics and instruments, and we just passed the 50-year mark. And that is our headquarters in Middlefield, Connecticut. So today, here's the agenda for today's webinar. So why come to Zygo for an ISR window? You can come to us for material expertise, market intelligence, optics manufacturing, engineering consultation. ISR windows are not your standard buy a piece of glass, grind and polish it. There are many nuances to designing and manufacturing the right window for your application. So the sooner you can get expert feedback from an experienced optical manufacturer, the lower the risk will be on your program. Zygo is material agnostic, so we do not grow or synthesize any material. So we can help you select the right material for your application. We can help view the different trade-offs between the various type of ISR materials. Our only interest is helping you choose the best material to fit your needs, so you can rest easy knowing that you're going to be steered towards the best material for your application. We also employ a multifaceted approach, which is going to give you the confidence to navigate all of the facets of ISR window design, fabrication, coating, as well as metrology. So selecting the right material is a very crucial first step, and it's going to either set you on the right course or the wrong course. It's very important to select material that has the transmission you need for your application. So thinner material will transmit more light, but it'll weigh less. Thicker material increases mechanical strength, but weighs more and can reduce optical performance. Window thickness can be a limiting factor with material suppliers. Processing sizes are currently limited by material availability. At Zygo, we have a variety of polishing machines up to 168 inches, and we can walk you through these type of decisions. You don't have to be an expert here. We know the different trade-offs of the raw materials. We know the manufacturing limits of the material suppliers as well as optical fabrication. Just for an example, over-specifying homogeneity, for example, is a cost driver. Homogeneity is typically selected to meet transmitter wavefront requirement. Aspect ratio, if a material is very thin, self-weight deflection can become a concern. Bubbles and inclusion at the surface of an optic would be classified as a dig. The material needs to be specified to meet the surface quality requirement. Another example that would drive cost is a thick CVD that chemical vapor deposition materials get very expensive with long lead times. And then we could look at silicon versus clear trend versus sapphire all have different costs as well as lead times associated with them. Crystal orientation is particularly significant for sapphire. Different crystal orientation will result in different substrate size limitations as well as birefringence concerns. A-plane sapphire is birefringent while C-plane is not. A-plane substrates have historically been available in larger sizes, more larger sizes than C-plane. Size limitations, ZYGO is not size limited in terms of fabricating large windows. The size limitation of certain materials such as silicon and germanium, in addition to sapphire, are dictated by the supplier's available technology. In addition to crystal orientation and stress birefringence concerns, bulk absorption is a critical parameter for HEL applications. As an example of a customer who needs a multispectral window that works in the visible and the midwave, these are the figures of merit that you'd want to consider. ZYGO has proven processes in manufacturing windows out of any of these materials, and we know the supply chain for these materials very well. We would make objective recommendations because we don't grow a synthesized material, as stated earlier. In addition to the properties listed on the material data sheet, window strength is highly dependent on the fabrication processes utilized. So how do you specify a window for your application? For ISR applications, you might consider controlled grinding of the edges and the bevels in a particular surface finish to allow easier mounting in a frame. For high energy laser applications, you may need to specify polishing the edge and/or bevels to increase cleanliness and achieve a better surface quality. ZYGO understands the cost ramifications when applying this to different materials. Specifying transmitted wavefront error. There are three key parameters: peak to valley, PVR, and RMS. So in using peak to valley, it's the height difference between the highest and lowest points of an optical surface. In other words, it describes the worst case scenario at a particular location. PV can be problematic because different instruments have different spatial resolutions and noise characteristics, and filtering is commonly applied to remove edge effects, ghosts, etc. Regarding PVR, ZYGO typically recommends the adoption of PVR in place of PV for the majority of circular aperture optics currently specified with PV. PVR is related to imaging and is robust over a range of instruments. ZYGO can send you a paper that we published that goes into greater detail on this measurement parameter. RMS is calculated as the standard deviation of the optical surface from the ideal surface. Small regions of variation will have less of an effect. And as a general rule of thumb, there's a 5-to-1 ratio between PV and RMS. It's important to specify transmitted wavefront error properly, especially on multispectral windows. ZYGO can test at various use angles as well as interferometers operating at visible and infrared wavelengths. To ensure the window will perform as tested in the real world, it's important to understand how the window will be held in its use condition. ZYGO's engineering team has the capability to design custom metrology fixtures to ensure the window will perform as expected. So these are the items here that you should think about when specifying your window. Flatness, parallelism, and transmitted wavefront all have interesting and different characteristics. So with flatness, it's important when an optic is used in reflections, such as a beam splitter, certain filters, or mirrors. Flatness describes that physical deviation of an optical surface and specifies a plane in which all portions of the surface shall be located. The parallelism between optical surfaces. So the maximum tolerance away from a perfectly parallel one surface can be from a second surface. Parallelism does not control the angle of the reference feature, but only creates an envelope in which the feature must lie. And transmitted wavefront error quantifies the deviation of a wavefront when transmitted through a window. One common mistake we see is specifying flatness on both sides of an optic and transmitted wavefront error. These specifications will conflict with each other on high performance optics. So how you would specify is you would specify flatness of one surface where reflection is most important and transmitted wavefront error. The second surface will be figured to meet the TWE requirement. Understanding clear aperture. Clear aperture, really how you design the clear aperture in reference to the edge of the part will drive cost and lead time. ZYGO can work through this with you and really go through the different parameters and what the cost and lead time drivers would be as you get closer to that edge. If you're using your window at an angle, you need to make sure you're not clipping your aperture as diagrammed in the figure on the below left. Wedge or parallelism. Is your window parallel or is it wedged? If it's wedged, you got to specify that angle, direction, and the tolerance. ZYGO has a lot of experience making windows extremely parallel. We're well below 1 arc second. And we utilize our patented MST interferometer to accurately measure tight wedge angles. Our ZYGO MST interferometer is a multi-surface technology interferometer, and that acquires phase data from multiple surfaces simultaneously. One measurement, one click of the button will report key metrics from individual surfaces such as transmitted wavefront, wedge, and even material homogeneity, as illustrated in the figure on the bottom right. Regarding coding requirements, these are all important aspects that need to be considered. On bullet 2, regarding the wavelength bands of interest, does your material support your coding requirements? Sometimes it's not practical to specify a high performance ultra broadband coating. In many cases, as this would usually require an R&D effort. Instead, consider which wavebands are the most important to your application. ZYGO can work with you to determine the best way to perform post-coat metrology, which is also extremely important. Knowing before an optic is made how you're going to perform post-coating metrology is key to your program. There are going to be trade-offs between spectral performance, environmental, and durability performance. All three can be quite unique. So ZYGO can help you work through this to reach the best specification for your application. Other things to note, is there a laser-induced damage threshold requirement? Packaging to protect the edges, how you package your optic. All those things should be specified early on. At ZYGO, we're more than just a build-to-print window fabricator. We make the instruments to allow us to verify the internal quality of a material. We have special polishing processes to correct any inhomogeneity that might be within the material. We have over 50 years of experience making critical flight optics. We've used tried and true methods to increase mechanical strength as well as lifetime. So if your application requires custom metrology, who better to come to than the company who wrote the book on optical metrology? We understand the end application. We can show you and our customers what their windows will look like under use. We have the ability to verify our models. Also, we can help to measure thermal loading and acceleration response and using things like finite element analysis. You need specialized tools to handle large optics. This is, I love this title because a lot of customers may not realize when you scale up to large optics, there are a whole host of things you need to consider. We've had customers that had a lot of experience designing smaller optics realize that once you move into the larger optics realm, it's not that easily scalable. There are many factors to consider. You need a supplier with infrastructure to handle large optics properly. Tooling, packaging, cleaning, transport are all aspects that need to be considered. Just as an aside, we've had customers take delivery of a large optic only to call us and ask us how to remove it from the crate. All of our personnel are highly trained and experienced in handling large optics, large fabricated and coated that are coded to be very demanding specifications. Our infrastructure throughout our whole manufacturing area is set up to incorporate several types of equipment used to lift and rotate optical components. As you see in the picture here, that one's rated for 1,500 pounds. Maintaining tight specifications over large apertures is very difficult when you start going into the realm of large windows. Metrology is more difficult. Handling and mounting and holding that optic makes it more challenging. We have 32-inch interferometers. We can do full aperture metrology and stitching on optics larger than 32. Material selection and limitations imposed by the suppliers, we can work through that with you. As you get into the larger area, you can also have issues with inhomogeneity, and also you can get size limitations based on the material manufacturer's technology. We can measure transmitted wavefront error over large areas. We can test assembled windows at use angle with different polarizations in their mounting configurations, also custom metrology setups. It's very important, but you can have trust in our metrology. So windows that are used in mission critical ISR applications will need to be refurbished over time. We have fabrication and coating capabilities all in one facility, so we can reduce program risks when multiple suppliers are involved. We routinely refurbish our customers' ISR windows. Another key attribute to ISR windows is strength. This is a report. This is a report that the U.S. Army did. It was a funded study on sapphire strength. It was called the SCAR report. It's based on sapphire. The U.S. Army took one sapphire material supplier, and they took 3 vendors, and they wanted to see whose process yielded the strongest sapphire. And ZYGO, who was vendor C, came out on top. The key takeaway is ZYGO knows how to yield maximum strength out of a material by using our proprietary processes. Staying with window strength, what many people don't realize, when grinding and polishing a window, tiny fractures are created that extend below the surface. That subsurface damage weakens a window. So how material is fabricated helps determine its strength. Because subsurface damage needs to be controlled, our proprietary processes yield that high strength. We've developed techniques to be able to control that subsurface damage over the decades. We have in-house engineering capabilities to design pressure testing fixtures based upon your application's pressure profile. In pressure profile information provided by our customers should include things like ramp rate and dwell time. Strain gauge measurements to correlate FEA results to an actual window assembly is something we can provide for you. Strain as a function of pressure, and principal strains are acquired real time during proof pressure test of a surrogate window. So in summary, we're not just a build to print fabrication shop. These are all the tools that we have at our disposal that can make a difference in your program. Please look to ZYGO as your early design and project collaborator. Sometimes if you work with a supplier that's strictly built to print, you may end up with a window that meets your specification, but it may not function properly. So we understand these are tough times on travel. We love to host people at any of our factories, whether it's Connecticut or the 2 factories in California. But in the meantime, until we can host you at one of our facilities for a tour, please, go on our website, go on our YouTube channel. There's videos of our factories as well as other webinars. We'll be sending out these links to all the participants after the webinar, along with our contact information. And I want to thank you all for taking time out of your busy schedules to spend a few minutes with us. This webinar will be posted up on our YouTube channel and our website. And just for a note, the next topic in our webinar series is going to be creating optical drawings using the ISO 10110 specification. That webinar is going to be given on April 22nd. So please follow ZYGO on LinkedIn, and we'll be sure to notify you when that webinar is getting closer. So we greatly appreciate you all joining us today. Let me see from Katie if there are any questions that came in.
Okay, we have some questions starting to come in. And the first one I see, we have glass inventory. Can we supply ZYGO with material? So the short answer is yes, we do have some customers who supply ZYGO with material to make ISR windows and other optics, but most prefer to have ZYGO assume the responsibility of selecting what is the most appropriate material for the application. Because the optical quality of any customer furnished material must be compatible with the performance specifications. And again, most customers would like to have that liability on ZYGO. And once again, we need to emphasize that ZYGO has absolutely no vested interest in promoting a particular material or brand. We do not manufacture material. ZYGO has excellent long-term relationships with suppliers for many different types of material. And our only interest in material selection is choosing what works best for your application in terms of technical, budgetary, and timeline constraints.
Excellent.
Okay, and let's see, we have a couple of others coming in now.
Yeah, we got about 5 minutes.
Please explain more about needing to know the test wavelength for a coated optic. Okay, that's a great question. So I'm going to give you an example. Let's say you have a systems integrator who is going to be performing assembly and they want to check the transmitted wavefront error at certain stages of their assembly process. We will need to know the test wavelength that they are going to be using. So very commonly, interferometers operate with a 632 nanometer laser, and ZYGO needs that information to ensure that the coating design and also the material will actually transmit at 632 nanometers.
Good question.
All right, and there are a couple of questions that are very technically specific, and due to United States export restrictions on technical information, we will be responding to you directly with our answers for those. So that should about wrap it up.
All right. Well, thank you. Thanks, Katie, for handling those questions. And for those that we didn't get your questions, we will be sure to reach out to all of you with a follow-up response. And we'll also get you those links as well as our email addresses. Thank you for joining us. We'll continue to post more optics webinars throughout the year. Thank you very much. Have a great day.
Thank you. Bye-bye.